So this shouldn't have any features created whenever it loads. Okay? So I want you to watch me. If someone gave me this data set and they were to say, I want to look at shape change and I want to look at actin polarization and determine which cells have actin polarized or not. We just show you that it doesn't have to take that long. Yes, I know I've been using software for longer than you have, but when you become familiar with the tools, then it's not too difficult. So here I just loaded it, and what I'm going to do is let's start with shape change. All right, let's start with shape change. So I'm going to come up here and I'm going to go to guided analysis and go to wizards, and I'm going to say, all right, let's do shape change. It's like, okay. So it recognizes that I haven't set my display properties yet, so it asks me, what do you want to do with this? Now, let me come in here under actin polarization and make sure we got the right. So actin is in the channel 2, under fit C, and the DNA is in channel 7. So I need channel 1, 2, and 7. All right. So let's go ahead now and look at 1, 2, and 7. I'm not going to worry about channel 9. I'm going to click on next, and now you can see it added color and set the display properties appropriately for these signals. Nuclear signal, side scatter, and actin. Right now I'm going to just come up here and label these. Actin, let's see, channel 6 was side scatter, channel 7 was nucleus, channel 1 was the bright field, and while I'm here I'm just going to go ahead and make them nice and square and pretty. I'm going to make them 80 by 80 or whatever number suits you. Okay. So it says choose the image you wish to determine the cell shape. So we're going to go with channel 1, which was the bright field. We're going to click on next. And so now it is calculating the features that it needs for that. Most likely it's calculating circularity, aspect ratio, which is one of the base ones. And so it's using the information. That's great. And now you can see that sometimes it crashes. There you go. Alrighty, so right, we said 2, 7, right? Next. And we're going to do shape change. Cell image was channel 1. Okay, now again, it walks us through these standard things. Best in focus, based on the bright field. Right now I'm just going to look at the bright field so that I can see more images. Go back up here and make these 80 by 8. 80. This one was 2 actin. This one was 1 bright field. This one was 7. Alright, so we now can look at focus, and pretty much everything looks to be fairly in focus. So I'm going to draw a focus line. Focus. Okay, and next. Okay, single cells. Well, these ones are my doubles, these ones are my singles. So I'm going to draw. Okay, kind of like that. And I can go back and change it later, but for now, that's where we're going to make it. And then because, I mean, one thing here is we are looking for shape change, right? So maybe I should include some of these down here because maybe they're just elongated cells, right? Like that one, right? Those are single cells, but they're elongated, so I don't really want to cut them out. Analysis. So next, you want to analyze subpopulations? No. Okay. Gate shape changed events. Finish. Apparently it doesn't like the shape change wizard. Okay. So this is now circularity. So if I come up here and I look at selected bin, these ones should have a higher circularity score. And if I look at channel bright field, these ones here should be more circular, and these ones here shouldn't be not as circular. Pretty clear, right?
So after you define your in-focal cells, did you get finished?
Yeah. It just walked me through this. I didn't have to create any features at all.
The circularity graph is how you can show.
Right, it created this.
Okay.
Okay. Now, the other way we can do this is say you're like, yeah, it's not really quite as clear cut as I want it to be. So what you can do is you can create your own tag populations. All right.
So how about the doublets? You put doublets on the right side, right? How do you get rid of those?
Hold on. What? These doublets? So what we would do is we would need to better define this here.
You made it a little bit elongated just so that there were longer cells. But
right, in case there were longer cells.
You run the risk of getting doublets. You know? So you want to keep it further to the left. Because the larger the area, the more likely you have.
See, so this cell is clearly a doublet, right? And it's right in there. So maybe what we need to do is adjust this up.
Or where is it? How did you show where it was?
You can't see. It's
did you? Can you?
Crosshairs. It's hard to see.
Oh, was it? So you clicked on it and then the crosshairs showed up.
Crosshairs.
Oh, I got
hard
you.
to see. I had the same problem trying to do some analysis. I didn't see the crosshair, but it's there.
Well, let me change.
It's just really small. Is there a way you can change the size of the crosshair?
You can't, but you can change the color behind it.
Okay.
Right? So if I change the in focus instead of blue, I make it pink.
I think that does throw people.
So right there, you can now see it better.
If maybe the crosshair was a circle or something, you know, that blinked, maybe.
Nope, and you can't change it.
They need to change that.
Right. So, all right. Here's still a doublet. It's kind of right there on the border. You might not be able to get them all out, but
How do you know it's on the border? Because you clicked it and it's crosshair.
exactly right there.
Can you click one that's not a doublet? You know, it's a little odd. Where's the crosshair?
Right there.
Yeah, no, I'm looking at like that one below the doublet.
Right there.
No, the 2585. Oh, is that 2585? It's, okay.
This one here is 1136, and it's right there.
Oh, I got you, okay.
Now, what you could do with this feature finder, back to your original question, is you would take, we could use another approach to doing this analysis. Okay, we could come up here and we could use this tagging thing, and we could say, all right, I want to compare round, and so I need to tag a bunch of rounded cells, roundish.
And you said about 25, 20?
About 20 to 25 is really the number you should be shooting for. Sometimes you can't get that high because you just don't have enough cells, and that is what it is. All right, so I've got 10. I normally would have done 20, but I'm just going to save that, and I'm going to label them as round. Okay. And now I'm going to tag elongated cells. Or not round, however you want to define it. Not sure whether that's two or.
What do you do to go down? I see.
Through there.
How did you move it down? Because I didn't see you go over to the scroll wheel.
How did I move what
You,
down?
you know when you kept.
Oh, I've got a little wheel on my
Mouse.
mouse, and I'm just.
Oh, I see.
I'm
Okay.
scrolling my mouse down. Okay, so right here we would save these now as not round. Okay. So now what I'm going to do is I'm going to come up here to Wizards, and I'm going to go to this Feature Finder wizard. And I'm going to say, okay, all right, I'm still in focus, single cells. I don't have any subpopulations, so I'm going to skip it. And now what I'm going to do is I'm going to compare those two populations, round versus not round.
So you're going to do the feature finder and reuse your focus and your single cells from what you've done before.
Yeah, you could do the feature finder to begin
I
with.
think a lot of people get confused on how you add, you do more to something after you.
It is designed for you to take truth sets, tagged populations, and compare them to each other. And then what it will do is it will search through all the features that it has, and it will create some new features. And if you have created features, it will compare those as well, and it will say, these are the best features that are going to separate these populations. Okay, so that's what it's doing now, is I've chosen round and not round. And now I'm going to say I want to compare all of the bright field features. Or I could just do shape or signal strength. I probably really only need shape. And let's also do size. Okay. And do I need to do any of the others? Texture, comparison, probably not, because we're really interested in the morphology. So shape and size make the most sense. So then you click on next, and now it's going to create all of the size. Find, and it has said the top two are length, height, major axis, aspect ratio, circularity, elongatedness. And now it gives you then the RD value. So length, based on the populations that I tagged, gives me the best statistical separation right along with height. And so it went ahead and plotted them, height versus length, and it said then that these ones have higher height and higher length. These should be elongated, these ones should not be. Aspect ratio is one that we already used, as well as circularity. That's the one that the cell. But this is all based on my truth set. Sometimes what will happen is I'll tag them all, and I'll get the separation, and I'll find out that it didn't quite separate it the way that it is, and I'll realize that my tagged population, I was biased in it. Like I didn't actually represent the populations that I wanted to represent.
So if your, say for instance, if your R4 was sort of, no.
Well, you can see how my R4 is kind of in the middle.
Yeah.
Right? It's sort of like incorporated into the R4 round versus not round.
Yeah.
It's probably because I have one cell that I defined as round that, based on these two parameters, fell into the same category.
Yeah. So ideally we want it to be like maybe, that the R4 box be like right above the blue box. The R,
yeah, in an ideal world, but
the green one is right above the blue.
But does biology work always in an ideal world?
So could that have been because we only selected a half the number?
Right, I only selected 10. So maybe if
So
I selected 25, it would have more parameters. Maybe if I selected 50, it would give me better numbers.
So we definitely need to have that number.
Yeah, or
to get good separation.
Right. The other possibility is maybe I defined it, but there really are two different features in there that I need to define. So maybe I need to pull this population out, tag two different groups in there to further separate that, kind of like what we did with the metaphase and anaphase.
Yeah.
Today when we were doing the analysis, when we looked at prophase cells versus metaphase cells, it separated them out really nicely, but within the metaphase population were all the anaphase cells. So I then took that group, did another feature finder, comparing anaphase versus metaphase, and it then gave me another statistic that separated those ones out. So now I then had my actual defined populations.
So should we maybe have just tagged on the fluorescence channel or something to go along with the bright field? Because this was just on bright field.
These channels, you see some are polarized and some are not.
Oh, yeah.
And so if I start using actin, this is going to be polarized, this one's not polarized. And so I could use this exact same feature finder to go through and tag polarized cells versus not polarized cells, do a comparison between those two, and it's then going to pull out a feature that's going to separate out polarized versus not polarized. So now I can analyze circularity and polarization and probably discover that those cells that are polarized have a higher tendency to not be round, right? And so then you can do a correlation that way.
So isn't it strange that it did not select circularity as the primary, the